As we get started now, firstly, thank you to everyone for coming to our first ever webinar. So I guess if you are one of our students and you're joining us, you probably already know what we do. But if you don't and you're new, basically what Coding Pals is we're kind of like a nonprofit organization, and what we focus on is teaching coding and math to students. And all of our courses are free, and our instructors are all mostly volunteers from the Lower Mainland and across Canada. So yeah, basically, if you're interested in learning coding or math, check us out. Our website is www.codingpals.org. And yeah, all right, I'll pass it off to David now, who will kind of give us the intro for our webinar.
Okay, so again, welcome to the first ever Coding Pals webinar session. Today we have an amazing panel, Nick Young and Jackie Zhao. They're both studying computer science at university and actually studied high school in Vancouver as well. The first speaker today, Nick, is a student at Brown University studying math and computer science and has a particular interest in databases and socially responsible computing. Nick, you have the floor.
Hey everyone. Once again, first of all, thank you to David and I suppose Kevin as well for inviting myself and Jackie to talk a little bit about how we got into computer science, how our path to computer science has been sort of so far, and also just like giving us the floor to talk to you folks. I'm seeing a lot of familiar faces in the panel. I also see another V1 hoodie, which is pretty cool, or like what appears to be a V1 hoodie, which is pretty lit. But yeah, I'm just gonna share some slides, visual aids, so that you aren't just gonna stare at me the entire time, and we can get started. So, hi, I'm gonna talk about computer science, but I suppose before I talk about computer science, I should probably talk a little bit about who exactly I am. I study math and computer science at Brown University. The math comes first because I think it's more interesting to me, but the computer science is probably the one that will be more important for this talk and also in my life overall. I'm also a teaching assistant. It's the main thing that I do here at Brown, aside from like studying. So I spend a lot of my time putting together materials for courses, putting together materials for students to learn, particularly about socially responsible computing, which I'm going to talk a bit about later. And aside from that, I also really like Minesweeper. If anyone else here plays Minesweeper, please give a shout and we can bond over Minesweeper. But otherwise, these are the 3 things you need to know about me to get through this talk. I mainly want to talk about 4 things in order. One, I want to talk about how I essentially walked through computer science into where I am right now. It's not the most conventional, but it's also not the most radical either. I want to talk to you a bit about, what you can do now, especially if you're very young, to get started with computer science now in high school, as well as a couple of things that I really wish I'd known before I'd gotten started with computer science, when I had. Lastly, I decided that it'd be a good idea to talk about my particular area of interest, the thing I spend the most time at Brown doing, which is socially responsible computing. It won't be heavily technical. I don't think that giving you folks a technical talk is the most, at least what I would be most positioned to do. I think Jackie is going to do something very interesting and technical. But I do want to give you something that you can walk away with, if you are going to continue in computer science, since, well, you'll see. Okay, first of all, how exactly did I get through computer science? And this part is going to be kind of like a pseudo memoir of computer science and me. So I really wish I could paint you like a really rosy picture of like myself falling in love with computer science through like algorithms and coding, or like through some really interesting, deep project that I did or whatever. But in fact, my first exposure to computer science was in like grade 7 when I was 12 years old, making like Minecraft mods. And at the time, of course, like Minecraft didn't really look like this. It looked a lot more like this. It looked kind of jank. It didn't look very nice. And making mods, getting into Java and a little bit of C++, not that Minecraft is written in C++, but I had learned it at some point, just like messing around. And I think a lot of people that are around my age, or perhaps a little bit older, got into computer science messing around. And I'll talk a little bit more about why I think this is a great way to get started in computer science. Unfortunately, after I got into Minecraft modding, I promptly fell out of it. didn't really stick in with it that much. The school I went to at the time didn't have particularly great computer science classes. Um, Jackie can maybe talk about this as well if he wants later. But there wasn't much of a drive for me to continue it in school, and as a result, I didn't really deal with it much outside of school as well. I eventually got back into computer science in my senior year of high school, studying like AP computer science, and then starting up with a bit of web development. And then I went to Brown to study math and computer science here. And at Brown, well, I suppose this is a good picture of what my school is like. Um, I studied math and computer science here at Brown University, as I've said like a billion times. I will say that my experience here at the school is probably not like what most people will have at other schools, in my opinion, at least. The courses are largely student run. TAs are the lifeblood of the computer science program here, which means that like TAs run all the assignments, they run even some of the lectures, all the sections, they do grading, writing assignments, writing labs, everything. So as a result, like I don't know if what I say about my college experience in computer science will be quite what everyone else will have had, which is probably good that we get more than one person on this panel. But what my school shares with all other universities is that it's probably not like high school at all. It'll most likely be a lot more project-based, much more collaborative, much more deep, and a lot more opportunity to do things that really are interesting to you. I see a raised hand. I don't know if I have the power to unmute someone, but if you want to ask the question, you can go ahead.
Guys, if you have a question, at the end we'll have a Q&A period. If you could save your questions until then, that'd be great. Thanks.
Okay, cool. But yeah, I don't know exactly what parts of my college experience are useful for you all to know, so I won't talk about it too much. Pretty much just taking a lot of math and computer science courses is very interesting, and when you eventually get there, you will figure out that every college is very different. So my advice won't actually be that useful, but I will take, super happy to take questions about it when the Q&A session comes up. So now I want to talk a little bit about if you do want to get started with computer science, how exactly could you do so? Understanding the position that you are in as high schoolers. Potentially your school doesn't have a great computer science program. Potentially you haven't done any computer science before, or perhaps you don't have an affinity for this kind of thing. Or you're just like kind of exploring, you want to get to know what the problem space is like. So, I poked around the Coding Pals website. This place seems like a great place to get started with computer science. They didn't ask me to do this. I just think that if you're already here, you might as well sign on to them. They seem great. And yeah, if they're cool enough to invite me and Jackie, they're probably cool enough to teach you computer science to some degree. But perhaps you're disenfranchised. You don't like signing onto programs to learn stuff, and you want to learn stuff on your own time or at your own pace. You've got this great resource. It's called Google. You can learn almost literally anything you want at any point in time. You don't need me to tell you that you can Google things to learn stuff, but I do want to push you to, if you, for some reason leave this talk with a particular penchant or wanton for web development, for example, just head on, search up how to do web development or how to make an app, and just keep browsing. You'll be really surprised with how far it can get you. And on that last point, really there is no substitute for just building stuff. No matter what courses you take at college or even in high school or extracurricular clubs, no matter what experience you might have in the past or what affinity you might have for computer science, there is no substitute for just going out there and building something. If you build one thing, you will learn the skills to build another thing, which will hopefully empower you to learn more and more things, to build more and more things. Yeah, there's no other way to go about it, in my opinion, at least. And there's a really good question of how the heck do I even get started with building stuff? Especially if you're in a position where you don't particularly know what exactly computer science entails or what things are that are good to get started with. Here are some a laundry list of things that you could potentially start with if you're interested in CS. So my personal starting point with computer science, outside of a course at my high school, was the web development. This is the development of websites and web apps, and just little services that you can make for other people. Web development is great because you can really easily share your work. If you make an app, you can, or a web app, you can easily show your friends and be like, hey man, you can use this. App development's on the same grain. You can publish things to the App Store pretty easily nowadays. Although I think if you want to publish to the iOS App Store, you have to pay for a license. Google Play lets you do it for free. And that's a great way to get into like development as well. On that grain, game development is really fun. There's so many libraries now with like Unity and Unreal that it's honestly pretty trivial to get started with making your own game. And if you're not really into making products or making, things that other people can use, maybe you really like hacking into things. You really want to know how like your computer works on a really low level. You can get into systems and security, pick up like any textbook on systems security. I feel like if you want a recommendation, I can give a couple of recommendations at the end. And figure out how to like hack your router or something, or send weird packets through your phone to some other service, which I have friends that do weird stuff with that, and they have a lot of fun with that. If I don't have a lot of expertise in this field, Jackie does, but if you're interested in making computers see, perhaps sing, listen to audio, or do like very, very interesting things that traditional programming couldn't accomplish, deep learning is a really interesting field. It's exploding. There's so much data nowadays that you can really get almost anything you want done, underline almost. And it's not super difficult to pick up and do without like a deep understanding of it. So picking up a random TensorFlow course and cracking on deep learning is, getting more and more achievable by the day. And like, this is just like my first top of the head list of things that you could potentially do if you wanted to computer science. There's so much more. You could get into like formal logic or programming languages, or so much more that I could not possibly put it all on the screen here, but these are the things that I think are the most accessible in decreasing order of accessibility to someone that might not have a lot of experience in this field. So the penultimate section of this talk, which is one in which I want to talk to you about things that I really wish I had known before I started computing. Things that I kind of got hung up on, things that like, I wish I'd spent a little bit less time worrying about and just kind of went ahead and did. The biggest thing is that I spent a long time, especially when I was really young, like when I was like 12 or 13, trying to like figure out like what was the best programming language to learn. And I framed my entire mindset around like, C++ seems to be the most powerful and like the most interesting one, like with applications to XYZ. So I must learn this one and only this one. Or perhaps like, Java is the most important language to me because Minecraft is written in Java. And Minecraft is is essentially gospel to me as a 12-year-old. Unfortunately, learning a programming language is very different from learning programming. One is syntax and one is semantics. And if you only do one, well, only learning a programming language is not going to be nearly enough to make you a good programmer. And my hope is that if you leave this talk with one thing, it's that you recognize the programming language you actually use is, for the most part, not super important to what you're actually doing. Yes, it's an important design decision in the program that you actually end up building. But for the most part, choosing a programming language to learn is pretty trivial. Choose one that you like. You like the way it looks, the way it sounds, the way it feels, and roll with it. It's more important that you use a programming language as the vessel to learn computing rather than as an ends, like you are just going to learn Java or C or whatever. Another thing is that there's a misconception. I don't know how this misconception works in high school, but especially at least in college, there's this conception that you have to be good at math to be good at computer science. This isn't particularly true. I know a lot of people that like really don't like math, but are really, really good at computer science. But I will say that like at college, at least, there is a lot of math in computer science. You'll find yourselves, at least depending on your degree program, perhaps in a lot of math courses. So if you have like a very large distaste for math, just sort of keep that in mind. But for the most part, you really don't need to be good at math to be good at computer science. It's super useful sometimes. Like logical thinking is a pretty transitive skill, and being good logically in one area tends to help you being good logically in another area, but not sufficient nor necessary. another thing is, if you're struggling to get the motivation to get started with a project or get started learning that framework you've been itching to get learning, future you will almost always wish that you started earlier. And this is not my bid to say, you're always going to regret whatever you're doing in computer science, but rather my bid is to say, if you're looking for a sign to get started, the sign is always saying now, and whenever you start, it will be the right time. So I really encourage you all to get started, Googling and just figuring stuff out, attending camps or whatever, finding online courses earlier rather than later. Another big misconception, at least at my school, and I feel like this is a pretty common misconception, is that careers in software engineering are kind of all desk jobs where you sit and code all day. This, to my understanding, could not be further from the truth for most jobs. Of course, if you really that's what you really want to do, sit at a desk and code for 8 hours a day, there will be jobs out there that in which you can do that. But I would say that many people don't exactly want that. They don't exactly want a homogeneous work environment where they just have them in a computer screen. And especially if you feel quite turned off by this, you'd be pleased to know that, at least in my experience, I've never worked in a place where I was forced to code for 8 hours a day and do nothing else. There was almost always, a client I had to meet with, or some other team I had to have a meeting with, or some cool activity to pass the time during lunch breaks or whatever. For the most part, you'll have a lot of free reign to do other things aside from computer science at a software engineering job. So don't feel turned off by pursuing a career in computer science just because you don't want to be coding all the time. Moreover, even if you study computer science and you don't necessarily want to do software engineering, the skills are incredibly transferable to other areas of the world as well. Perhaps you want to get into biology, and your biology lab really needs someone to run data analytics. Perfect, because you study computer science, you know how to do that. Or you start working at an automotive company building cars, and all of a sudden someone needs to verify that the integrity of a car is going to be fine computationally. Great, you study computer science, you can do that. So regardless of whether or not you actually end up pursuing computer science primarily, this will be an incredibly useful skill for you going forward. Which leads me into my last point, or last thing that I wish I knew about computer science, is that it is incredibly powerful. And I mean this in two senses. The first sense is direct. It is that you can do a lot with computer science, and that is pretty cool. You think about the biggest household company names that are shaping your life today. Think your Googles, your Netflixes, your Microsofts, your Apples. Companies that you might not think about every single day, but whose impact you interact with every single day. And the engineers at those companies have great reign to influence your life, which on one hand is really, really cool if you want to be one of those engineers. On the other hand, if you're not one of those engineers, it can be really daunting or scary, or if you're like me, just interesting. Which brings me to the second sort of take on this point, which is that computer science is incredibly powerful, which means that if you want to study it, you have to understand that with great power comes great responsibility. Which brings me to my last sort of section of this talk, socially responsible computing. As I said, I spent a lot of time as a teaching assistant, and part of my work as a teaching assistant is teaching students or designing material to teach students, what exactly is the impact of the code that I'm writing? When I write an algorithm that finds the shortest path between two nodes, what exactly does that mean in the real world? What exactly does that look like when I deploy this to some server, have millions and millions of people interact with it, and eventually have some metrics come back with some user data or whatever? What exactly does that mean? And the motivation behind this is exactly what I just said. There's this old Spider-Man saying, great power, something or other. And a lot of people tend to forget about this, especially when they're on the job. When you're at the job, it can be really easy to forget that, your 20th graph algorithm of the week actually will impact somebody's life. And it's very hard to see past the lines of code into the real world. And a lot of my work as a teaching assistant motivates students to get out of that mode of thinking of just thinking about the code and into the mode of thinking about, what is this code going to do in the real world? How is it going to interact with people, other companies, other stakeholders, and what kinds of impacts are they going to have? So I know a lot of what I've been saying in this specific section has been really broad and vague. So I'm going to color it with a couple of examples. Let's say you have a machine learning model and it's biased. For example, your dog classifier classifies, no, this is an awful example. Let's say like you have a machine learning model that generates faces, but perhaps the faces it generates are only of one gender. Then if you want to generate faces of another gender, you either can't do that, or you've made an assumption, the only faces that exist in the world are those that look like this and the other ones don't matter. And of course, there's like so many examples in machine learning. I don't want to spend too much time on it because they're pretty easy to think of. But the idea is that if you're going to make software that does something, especially qualitative, you better be sure that what you're doing takes into account the biases that the world might have around it might have. Or for example, let's say you're making a database and you've made a database that doesn't take into account the fact that somebody in your database might not have come from Canada. So what that might look like is your postal code field only accepts things of the form letter, number, letter, number, letter, number. So then anyone from the United States comes in, they say, I can't use your database. Anybody comes in from overseas, they say, I can't use your database. And of course, there are like a lot more examples of perhaps more socially impactful exclusions. For instance, maybe you don't have very flexible fields for race, gender, or sexuality. Maybe you don't allow people to express more complex naming conventions. Maybe someone has two first names and you want to somehow honor that. If you didn't design your database in a well enough way, these are people that will be actually impacted by the decisions that you made as a computer scientist, as a software engineer. And it's important that, when you're making those apps, when you're making those programs, you take these people into account and you don't forget them in the process. Or for example, let's say you made like a mapping program, a program that shows you what the world looks like, a Google Maps of sorts. But then you forget that certain countries don't exactly agree on what borders look like. For example, like on some maps, it's actually a really interesting example. If you look in Google Maps from Canada versus if you look at Google Maps from, I think it is like Bhutan or something, certain borders won't exist anymore, or certain borders will be there that weren't there before. And Google's really smart in that, or I'm not sure if this is smart, but it's interesting in that depending on where you're viewing their maps infrastructure from, they'll show you the map that most conforms to the place that you're from. And let's say you didn't do this, then a large portion of the world, might refuse to use the software because, it doesn't reflect the map they know. Or perhaps you've given them an inaccurate map that could put someone's life in danger. So this is another really important consideration. Just another example. And the easiest thing to say when it comes to a lot of these examples or these cases where computing goes wrong, where computing ends up hurting people, is essentially like, why should I care as a developer, right? Like, isn't this the job of the higher ups or the job of the product managers or the people that are telling me what to code to figure out how to do? Or perhaps it's the job of like politicians or the job of economists to figure out whether or not the code that someone else is producing is good. Why should I, as a developer whose primary job and function is to write code, care about the code that I'm writing outside of my window? And the main idea is that because software engineers have great leverage as as essentially the progenitors of all code. If there weren't any software engineers, there really couldn't be any code. I mean, unless you don't count anyone who doesn't code as not a software engineer. As a progenitor of all software, if you refuse to make software because it aligns with your beliefs, you can make the world essentially a better place. Assume your company comes up to you and says, hey, can you make this mapping software? And you say, have you thought about XYZ, about the ways in which your software, as it stands in the way that it's been modeled to me, could hurt someone? And if you refuse to, maybe you put your job on the line, but if you really do believe strongly enough that what you're going to be building is going to be harmful, then they'll be forced to reconsider. They have nowhere else to go. They can't just like, I mean, they could just fire you and hire someone else, but if that someone else also does the same thing, which is the hope, software engineers as a collective can have great leverage over the life cycle and trajectory of software structures over time, which is really, really powerful. It means that you as a software engineer, if you decide to be one, has great power over how your software will interact with other people in the world, whether or not it will hurt people, whether or not it will end up being a boon or a burden in the real world. And so, especially if you decide to stick around in computer science, but even if you don't, it's really good to think about whether or not the software you're using and building is going to end up hurting people or not, whether or not it's going to actually, have the impacts you want it to have. Because if we end up making decisions based only on like whether or not this is going to drive profits up, or whether or not this is only to get more clicks on our ads, we get situations where Facebook ends up ruining the mental health of millions of people around the world, or where Uber ends up like underpaying everyone because they couldn't be bothered to add tipping infrastructure for a long time, or for example where other really popular apps such as like say like Spotify displace huge music industries and make it really difficult for other people to share music. I'm not sure if that has happened, but if it did. So the key takeaway is you should never forget how important your work can be as a software engineer. It's really easy to, but if there's only one takeaway that you should take away from this talk, it's that if you decide to pursue a career in this, you should be sure that you're going to have to continue thinking about the world at large. It's not good enough to just sink into the code and forget about everything else happening around you. All right, that's all I wanted to say. Well, that's not true. That's all that I have time to say. Hopefully you have great questions for myself and Jackie at the end. Here's my website if you want to learn more about what I'm up to, what I'm doing. There should be an https:// in the front, but I think it looks prettier without it. That's the end of my talk. I'll hand it back over to David to introduce Jackie. Thanks so much.
Okay, thanks, Nick. Now we have Jackie, a computer science student at UBC and also a logistics director at NW Plus Hacks. Jackie, you have the floor.
Well, hello. Yeah, thank you, David, for the introduction, and Kevin, both of you for having me today. It's like a pretty cool event just to see so many young people interested in the field of computer science. And like Nick said, like you guys are the next generation of people who are going to be shaping how we develop software eventually. So it's really cool to see a lot of people interested in the field. Yeah, let me just share my screen just so I can share some slides with y'all. But yeah, TLDR. Like David said, hi, my name's Jackie. I'm currently in my second year studying computer science at UBC, and here are a few of the things I'm interested in. Don't worry if some of these seem like awfully buzzwordy or if it goes over your head. I'll be briefly covering it, but if you have any more questions about them, I'm happy to answer them in the Q&A section afterwards. So the first of which is cloud infrastructure. Cloud infrastructure you can think of as code that supports other code. So it's like, say you want to run a Minecraft server. If you want to run it for just your friends, yeah, you could probably run it from your own machine. But if you want to run it for hundreds of thousands of people, your computer's probably not powerful enough to do that, right? So you can offload that to somewhere else, so possibly a bigger server that's sitting on the cloud somewhere. And the essence of cloud infrastructure is creating that type of infrastructure that you can kind of worry only about writing your code and don't have to worry so much about deploying it and hosting it and whatnot. The second of which is second field I'm really interested in is machine learning. So machine learning, also very buzzwordy, seen a lot in the news nowadays, is the act of using data and stuff that we see in our day-to-day world, and a lot of the data that a lot of these bigger companies collect and use them to make predictions about how things will behave, or yeah, anything about like things in the future. So for example, if I have a large section of text and I want to find out if I want to generate more text based off of that, or if I want a system to figure out what I'm saying right now based off of my audio. And there's a lot of really interesting applications of machine learning. Kind of as like a nice segue into the next point is ethical AI. I think machine learning has a lot of great potential to change a lot of our industries in the next like 20, 30 years, or even like next 5 years. And I think a lot of that will come down to how we choose to utilize machine learning and artificial intelligence. Like Nick said, like socially aware like computing is something that's really important. And we have to make sure that we're using these powerful tools in ways that are actually beneficial towards people and not just exacerbating the biases that we have. And yeah, I was going to talk a little bit more about ethical AI, but it looks like Nick already covered most of it. So I will leave that to the Q&A period if we have more questions about that. Last but not least is cognitive systems. This is something that I've discovered newly in university. It's like a really interesting intersection of philosophy, linguistics, psychology, and computer science. A lot about asking questions about like, what does it mean to be human? Can machines ever be intelligent? And what does it mean for computers to think? And some interesting questions like that. And I think a lot of the answers to those questions will have impacts on how we consider developing, for example, like policy around regulating machines, artificial intelligence, and computer science in the future. But yeah, enough about kind of what I'm interested in. I'll talk a little bit more about how I got into CS and like where I am right now. Much like Nick, I got into CS through some rather questionable means. I found out about Scratch in grade 6, grade 7. Scratch is like a very graphical programming language for drag and drop blocks. I'm not sure if any of you heard of it, but it was one of the first the first places where I came across like quote unquote programming. I spent a lot of time on Scratch making video games, as you do when you're 13, 14. And I really liked just being able to see like something that I could do physically on my computer transfer into something that I could tangibly interact with and share with other people. And that kind of carried over to Minecraft, where I started making mods and then running servers with my friends too. And like Nick said, I think one of the best ways to get into something like CS is like find something you're interested in, whether that be video games or whatever. And eventually you'll find something that interacts with the internet at some point, and with computer science. So that was kind of my first like basic introduction to computing and CS. In high school, I decided to try my hand at science fair. And this was my first real like longer term project that was like more than just like a Scratch game or whatever. And for my science fair project in grade 11, I made pretty much what was like a device to help the hearing impaired translate speech to Braille. So, and that involved a lot of research on, first of all, like how do I make a device that does Braille stuff? Two, how do I make an algorithm that listens to audio and turns that into text? And three, how do I put that into the hardware? So there's a lot of really interesting questions that I'd never really thought about up until that point. And science fair was like a really good motivation for me to learn a lot of those things and then keep persisting at it for a long period of time. So science fair, I think, really taught me a lot about making sure that like my goals for and expectations for longer term projects are reasonable, how to go about researching, and to be persistent with things that I do. Yeah, I think science fair was like a really good learning experience in just getting into software and learning to actually build software over a longer period of time. And it was the first time I've had experience with people in the community. As I was learning a lot of the necessary skills to do science fair stuff, I ended up stumbling all across like Stack Overflow. It's like, how do I convert a tensor to an array? And I had no clue what I was doing. So a lot of it was just fumbling around on Stack Overflow and trying to figure out what all these words mean. And I think a really big part of these larger projects is you eventually learn to get really good at learning, which is kind of meta in a sense, but I think that's what a lot of computer science as a whole is learning to learn, and being able to grasp new things really quickly. And I think that's a really big part of it. Next part is hackathons. Also in grade 11, me and Nick have a mutual friend called Matthew Katz. He's also was from our school, computer science god. Dragged me into a hackathon called NW Hacks at the time. And it was the first time that I've heard of something called a hackathon. You might be wondering, like, what is a hackathon? Pretty much a hackathon is like a 24 or like 48-hour like make-a-thon where a bunch of people get together and build cool software and to solve problems, which is like a really cool concept if you think about it. And this was the first time like I physically went to a location, saw a bunch of people who were really interested in the same things I was interested in, and like with a lot more technical skill than I had, that were building really cool things. And I think that was served as like a really big point of inspiration for me to dive deeper into the world of computer science and software, just to see like, okay, this is something that I can eventually get to and build in the future. And that was really inspiring for me. And over the years, I started attending more hackathons, NW Hacks being my first one. I did Hack the North in the same year as well, which was at Waterloo. And I think I've racked up, I think around like 10 now. It gets addicting after a while. But yeah, I think hackathons are a really wonderful way of building up this necessary skills to be able to build projects, as well as meet some really, really cool people. Last but not least, in the summer year of my grade 12 year, I was fortunate enough to be able to intern at Hootsuite, which is a Vancouver-based company that specializes in creating like an all-in-one social media platform to help people manage their social media. And Hootsuite actually does hire high school students for software engineering jobs, which I didn't find out until like a few months before the application. What I'm really glad I did. I think Hootsuite was a really transformational experience for me as a computer science student. It taught me a lot about, I think like imposter syndrome. So like feeling like you don't belong and you're an imposter among a group of people who will find you out as fake. And just developing a lot of the right skills and being able to ask the right questions, being able to ask for help, most importantly, and yeah, just developing technical skills. And I'll also be happy to answer any more questions about Hootsuite later in the Q&A period as well. Yeah, next up to a bit more about currently what I'm up to. I've transitioned away from doing more like attending hackathon stuff and more toward the organizing side. So as you may or may not have heard of, NW Plus is a larger umbrella organization at UBC that does organize a lot of hackathons. So we organize NW Hacks, which is one of my first hackathons. So it's kind of like brings me back full circle, which is kind of funny. And then we also organize a bunch of smaller hackathons like Command F, which are focused on female identifying hackers and helping more traditionally underrepresented groups get into the field of computer science, as well as Local Hack Day, or now rebranded to Hack Camp, which focuses more on beginner hackers and high school hackers. So if y'all are interested in that, you go to nwplus.io. It's a little plug from my end, but yeah. I guess more about what I've been up to as well is building side projects. Now that I actually have like the technical skills from attending hackathons and just working on stuff on my own time, I feel like Nick said, like CS is a very iterative process, right? The more skills that you get from building one project, you can apply to the next one. And I feel like I've gotten to the point where I have the necessary skills. I need to just be able to find things to apply them to. And that's kind of what building projects is all about. I think computer science is inherently, actually, computer science is very like human-centered. Tech is a tool to help us solve inherently human problems. And I think at the core of it, we should be focusing on human problems and seeing how we can apply technology to it, rather than trying to figure out a technology and then trying to mash it into some sort of problem space. Other than that, I've been doing a little bit of freelance and open source development on the side as well. So contributing to larger projects like Bento ML, which is a framework for machine learning infrastructure, and doing freelance development for a few small companies. But yeah, I guess a little bit more or less about me. Tips on building projects. I know when I was first getting started, I was very much trying to figure out how I best learn as a computer science student or like a software engineer. I tried a bunch of things like doing online courses. I found that online courses didn't really work for me. I'm a very hands-on learner. So I found that just like diving into tutorials and just building projects on my own was the way I could most quickly learn something. And that's kind of the approach that I've taken towards developing ever since, just finding projects to work on, finding interesting problems in the world around me and seeing if there's any way I can solve that with something I know or even something I don't know. I think one of the biggest pieces is like, you don't have to know everything in order to build the project. I feel like for most of the, I would say 90% of the projects I work on, when I'm heading into it, I know maybe at most 35% or 40% of what I need to know to actually finish the project. And most of the fun of the project is the learning along the way and building those skills. I think one part that makes building projects really, really fun for me is finding a really good community of friends and people who are also interested in the same things that you are to build stuff with. I think surrounding yourself with amazing people that help bring you up rather than tear you down is actually a very underrated part of, I guess, like software engineering. Software engineering is inherently collaborative. There is no modern software system you see today that was built by one single person. Even Minecraft, which is like known to be an indie game developed by one developer, that's powered by a lot of tools and languages that are built by other people too, right? And I think as a part of that is like making sure that you know how to collaborate with others on developing code and making sure you have good ways to go about doing that. Like I said earlier as well, building projects is a great way to learn how to learn. School also does this really well, and I think that's like the biggest part that transfers really well from university is you get to learn things really quickly, and I think that transfers over to CS really well. This is more of a personal opinion, of course, but I think if you're here to just learn how to code and build websites, I'm not sure if university is the right path for you. University is definitely much geared towards a much broader understanding of the world at large and giving you the necessary toolkit to go about and approach problem solving. If you want to just build software, I think boot camps and software boot camps and online courses will do that much better than university ever will. So yeah, I think if you are definitely more interested in like broader problem solving at the global scale, then I think university will provide like a really good baseline knowledge for that. Yeah. Last but not least, worry less about the technology and focus more on the learning and building aspect. I think Nick touched on this briefly as well, but like you shouldn't be worrying about like, oh, whether I should be using like C or Python for this project. I think the main part of it is first of all getting started on it. I think technology is a very iterative process. You can get something that works out that is a working prototype so that you can test it with real people, or you can test it on yourself and then work towards a more refined product that you can then launch. But yeah, I think that's like the TLDR of all of the tips that I've kind of accumulated over the years of building projects. I was going to talk a little bit more about ethical AI stuff. I think Nick has covered that really well. So I'm going to end my part of the presentation early and just leave the floor to questions. Thank you, everyone. And hand it back to David.
Okay. Thanks, Jackie and Nick. I hope everyone learned something from their presentations, as it was very insightful and they were both extremely knowledgeable. As a prospective student myself, I found that all of that to be very helpful. So we'll now be opening a Q&A period with the questions you guys sent us in the Google form. So I'll just start sharing my screen now. So if Nick or Jackie, you guys just want to like jump in to answer the questions. The first question is, what's one piece of advice you would give to students interested in pursuing post-secondary education in computer studies? So I guess we can start with Jackie because you just presented. So go ahead.
Yeah, I guess I like briefly touched that on a little bit on that at the end part. I think the biggest part of university is teaching you how to learn, and I think the biggest part of making the most out of your like post-secondary education in computer science or computer studies is find out what opportunities are available at whatever institution you're at, and make the most out of it. I think heading into UBC, I knew NW Plus existed, but I didn't know to like what impact, like what scale it really existed at. And after joining NW Plus, it was like truly a very transformational community of like people also interested in CS and bettering the CS community for and improving it for future generations to come. And I think that has played a really pivotal role for me in seeing how I approach not only computer science, but like community building and just existing as a person in general. So I would say like, yeah, one piece of advice, just make the most out of whatever opportunities you have related to computer science or even not related to computer science at your university. And I'm sure that will transfer well.
Okay, great. Nick, do you have anything to add to that? Or?
Yeah, sure. This will really depend on where you end up going to pursue computer science. I want to echo what Jackie said in that, like, if you're just interested in building like building software, you're not interested in much else other than that, then university for computer science might not be for you. A lot of what you learn in a university level computer science program, you might not actually end up using like in an actual job. At least in my experience, a lot of what I've been learning, I like explicitly know that I will never actually use in a job. And a lot of like what you learn at a degree program, you'll be learning out of pure interest or because some requirements that you had to. That's just one small thing. The bigger thing that I wanted to give as sort of advice is that depending on where you go, you'll face people that are orders of magnitude smarter than you could ever imagine someone could ever be. And imposter syndrome hits really, really hard in college. It hits even harder when you get like to an internship, but especially like in college, like depending on where you end up at, the people around you will most likely seem, incredibly bright, incredibly put together. They already know what they're up to, and things can seem really, really scary. My biggest piece of advice is know that they are all also feeling the exact same thing, and you're all there just to learn, nothing more and nothing less. Aside from like maybe getting a job, but for the most part, if you approach school with the mindset of I'm here to learn, I'm here to, maybe get a degree, and I'm not here to compete with everyone else. I'm not here to just like, for clout reasons or to appear better than my peers. You're gonna have a much better time.
Okay, great. I think this next question will be especially interesting. So, what is your favorite thing about pursuing a degree in CS? You can also talk about some things you enjoyed and some things you didn't really enjoy, and maybe things that just more advice, I guess. So, I guess we'll start with Jackie again.
I actually don't have like a top favorite thing right off the top of my head. I think, actually, okay, I do. I think the community. I think a degree program or like university in general is like a great way to get a bunch of people who are interested in the same thing together. And I think the people that I've met through pursuing computer science have made a really big impact on my life in how I choose to approach problem solving, computer science, and life. I think the community, the community part of pursuing a degree in CS. Because if you do a boot camp or online school, it's like, or just like online classes, you don't really get a lot of that same feeling of like having a community that kind of supports you in that way. So yeah, I would definitely say community.
Okay, great. Nick, do you have anything to add to that, or?
Man, there's so many things. I love TAing. I love teaching. I love, probably most of all, I love learning like niche things that are just cool. Um, I'm studying math and computer science, and as an extension, a lot of the courses I take aren't really like applicable. They're just like things that I think are really interesting, and I take them because like, because they're cool. I'm taking this one class right now called Logic for Systems, in which we use like tools that resemble programming languages but aren't actually programming languages to logically model systems so we can detect bugs in systems without ever looking at the system's code, which is really, really cool. Like, for example, you can model like an encryption scheme, and without even looking at how the encryption scheme was implemented, detect ways in which that encryption scheme could be exploited, before you write a single line of code, before you write any tests. Super, super cool. Also, like math courses in college are unlike math courses in high school. You get to learn really topics that like are not like stuff you've ever encountered before. So I'm taking right now graph theory, which is the study of like basically dots and lines. When you connect a dot to another dot, what are the implications of that? So I don't know, math and just coolness of it.
Okay, great. I think we'll now be opening questions to anybody in the Zoom call right now. So if you do have a question, raise your hand and we'll ask you to unmute. Kevin, yeah, just go, and Kevin will choose one of you. Yeah. So if you have any questions, you can unmute and then ask it. If not, we'll go on with the next question in the slides. So, okay, we'll just go on with the next question in the slides then. Next one is, I think some of you or both of you have already sort of answered this in your presentation, but what is one thing you wish you knew before you chose CS? Yeah. So Jackie, we'll start with you again.
Yeah, I think Nick touched on this as well, but I think one other thing that I wish I knew better was like the degree to which you will feel imposter syndrome. Like Nick said, like there's always going to be people so much smarter than you are that you could ever hope to imagine. Like I met a 15-year-old the other day who knows more about industry coding than I have met like senior engineers who do, and it's kind of insane. and it's very hard sometimes to like not compare yourself to those people. Like, oh, I wish like I did this when I was younger, and oh, like I should have studied this instead, or I should have learned this language or whatever. I think a lot of it is knowing that everyone kind of has their own path and approach to learning computer science and software engineering, and that like whatever pace you're going at is okay. And the biggest part is just finding a community that supports you in your learning, and tries to minimize that imposter syndrome feeling as much as possible.
Okay, great. Nick, do you have anything to
Uh, I wish I knew. I kind of already knew, kind of, but I will say that like studying computer science at college like isn't the easiest thing in the world. I kind of wish I knew how hard it was going to be, so that maybe I could make an informed decision about like about everything. But that is like the last thing I want this to be is like a turn off for anyone that like wants to study it. More just like a precautionary tale. Like if you're expecting something that's like easy to walk into and easy to get like a degree, like this is the last thing that you should be putting on your list.
Oh, okay, great. I think we have one question that I just got sent. So the question is, how do you get offers from tech companies? I know this is probably a bit loaded question, but maybe just like general parameters or like how you guys see the experience in trying to get offers from tech companies. Nick, Nick, you can start this, I guess.
By applying. I don't know if there's a better answer. If you don't apply, you just have to apply. Give them a resume, see what happens. There's no better advice. I don't know how the hell I got an offer. I don't think anyone really knows how I got an offer. What happens behind closed doors happens behind closed doors. And neither of us are admissions officers for these companies or recruitment officers for these companies. So send an application. There's no other way to get applied or get offered.
Yeah, I would plus one on that. It's like, I feel like getting into tech companies is very much like getting into universities. A lot of it is a crapshoot. Just like there's incredible volume of applicants for some of these positions, and it's even if you're the most qualified candidate, sometimes you'll just get screened out just because you're unlucky. So I think a lot of it is one, volume, two is finding connections. You'll be surprised how far a personal connection will get you through some of those initial like very BS stages of resume screening and whatnot. And I think, yeah, three, find people to grind with. Practicing LeetCode is not the most entertaining thing unless you just absolutely love sitting and just like typing solutions to programming problems. So just finding a group of people that will make that more enjoyable for you is nice too.
Okay. I think this will be the last question, but so why did you guys specifically choose UBC and Brown for CS? I guess, Nick, you can start this one off. Yeah.
Shoot. Okay. Hello.
Yeah.
Well, honestly, like when I was choosing Brown, I wasn't really choosing for computer science. I kind of had an inkling that I wanted to explore it, but something that I left out was that I didn't really apply to Brown for computer science. I applied for political science. And in my first semester, I was doing mostly engineering and pre-med classes. So I did not exactly choose Brown for CS. That being said, in hindsight, this was a really good choice for me. I don't know if anyone here really knows about Brown, but I can talk about it at length, or you can read about it online. They have this weird little thing going on where their grades are pretty lenient. There are only A's, B's, and C's, and you can take any class you want, pass, fail. There are no restrictions between departments. So if I wanted to take a class in the archaeology department, which I have, I can, without having to worry about registration details or whatever. And I don't have to worry about like being semester locked. So I'm taking a lot of graduate classes this semester, despite only being in my second year. Just the freedom to do whatever the heck I want is really, really great here.
Yeah. Jackie?
I'm gonna say my university choosing experience was pretty simple because I only had one offer to choose from. So UBC CS it was. I think in hindsight, looking back on it, I think UBC was a really, really good choice just because I think there's a lot of schools where CS programs are super, super cutthroat. And there's a lot of competition about, like, for lack of a better word, it's like it's a measuring contest to see who can like do the most things or like be the best or whatever at whatever. And a lot of people lose sight of why they were interested in CS in the first place in an attempt to climb up this like non-existent ladder. And I think at UBC, like that mentality is not really there. A lot of it is just pretty mutual support of one another and helping each other like actually want to achieve better things and become better people, which I think was like a really nice change of pace from high school. And I think really helped me thrive as a person.
Okay, great. I think we have one last question that was in the chat. So what is something specific about Vancouver? Because I know both of you took high school in Vancouver. What is something specific in Vancouver, like any organizations or competitions or just things you can do as a Vancouver student to like help further your career in CS or just anything interesting like that? Yeah, so if any of you want to go, I guess Nick, you can go if you have any ideas.
I mean, I didn't do much computer science aside from like just myself in high school. I will say that doing things that you like doing is much more important as a high schooler than doing things because you want to like, meet some ends like college or whatever. For me, that thing was Model UN. That thing is transferred over really, really well to my degree at Brown. I consider myself decent at public speaking, good at like managing large sets of large programs or whatever. With some stuff that I all learned through Model UN. I'm sure if anyone here knows me, it's most likely through that. Yeah, I don't know. I'd highly recommend just doing what you want to do. There's no substitute. High school is a time to enjoy yourself. It only gets worse. So
Yeah, Jackie?
Yeah, I agree with all those points, but I'd also like to add on and saying like I feel like the CS scene in Vancouver has been growing a lot these past few years, and has been a lot of newer programs that have been established, and like hackathons and programs are targeted more towards high school students and younger people who are interested in it. I think the biggest ones I know of are, I think Vancouver Hacks was a thing. I don't know if they actually ended up running the event or not, but it was a hackathon dedicated for high school students. That was for people in Vancouver. This is also more of a self plug, but NW Plus is also runs a lot of beginner focused hackathons, and I highly encourage you, if you're interested in getting more experience and meeting some really cool people, to attend some of our events. Like we actually have like a really high ratio of people who are still in high school, so don't feel intimidated like, oh, I'm going to be among a bunch of university students. Like there are a lot of fellow high school students who are interested in the same things that you are, and I think it's a great opportunity to find those people who are also interested in the stuff you're interested in and meet them.
Okay, I think that's the end of our webinar session. Again, I want to thank both Nick and Jackie for coming. I know it's probably very busy for you both, especially because you guys are both in university, got a lot of homework. So thank you guys all for coming. Yeah, so if you want to stay behind or ask any questions to Nick and Jackie, just like one-on-one or anything like that, you can feel free to stay behind. But yeah, thank you guys so much for coming to our first webinar session. You guys are free to go now. Thanks.